Hello student, we are going to discuss today the chapter name motion. It is chapter number 8 of your science. So let us start motion. So first of all, what is motion? Day in and day out you come across many kind of motion like birds are flying, children are playing, people are walking, vehicles are moving. So these all are example of the motion. So can we define motion? Yes, we can. So motion is when object changes position with respect to time, it is known as motion. For example, you are standing at the platform of the railway station and train is there on the track. So you are here, train is there, and after some time, let's say after 5 minutes, train is also there and you are also there. So can we say that train is in motion? No, it is not a motion. But after let's say 5 minutes, you are still there on the platform, but train is not there. So train has moved. So this is the example of the motion. Okay. So what very important thing is the position of the object should change with respect to time. Now, is there any example in which we cannot come to know about motion directly? The example we have discussed of train, we can come to know that train is in motion directly. But is there any indirect example? Can we see the wind? No, we cannot see. Then how we can say that wind is there? So we can come to know about such thing by some indirect evidences. For example, the leaves are moving or dust particles are moving, the branches of the trees are moving here and there. So we cannot see wind directly, but by some indirect evidences we can come to know about the motion of the wind. Is there any such example, any other example? Can we see the motion of earth, be it around the sun or be it on the the rotation on its axis? We cannot see, we cannot feel, but how we can come to know that earth is rotating? We can come to know by indirect evidences like days and night occurs or season changes. So these are examples of the indirect evidences. The next thing is relative motion. To describe anything, whether it is in motion or not, the concept of relative word is very essential. For example, you are sitting in a train or you are sitting in a car or bus, and the person is sitting next to you. Now, whether the train or bus is steady or it is moving on the road, the person sitting next to you is always remain stagnant with respect to you. Yes, but when we take the opinion of the some other person who is not in the bus or who is not in the let's say train, who is sitting by roadside, then for that person, you and the person sitting next to you both are in motion. So from one point of view, it is not motion. From your point of view, the person who is sitting next to you is stagnant. But from the point of view of the another person who is not in the bus, who is not in the train, the motion is there. So motion is a relative term. Motion is the relative quantity. Now, to describe the motion, first of all, to locate the position of any object or any particle is very essential. We used to, for example, give our address to somebody. Let's say, so when we are giving address of our house, our residence, there is a specific position, specific house number, flat number, street or some area and district and town and whatnot. Then and then we will be able to locate something. In the same manner, to describe the position of any object, we need a reference point. So reference point is the address of that particular particle or that particular object. We can say that my house is 1 kilometer away from the railway station. So that railway station is the reference point from which we can locate your house. Is that clear? So there are many kind of the motion, be it a motion in the straight line or circular motion, vibrational motion, rotational motion, and there are some equation of motion by graph. So in this chapter we are focusing upon motion in straight line, circular motion, and equation of motion by graph. So let us start with the motion along straight line. Here let us take the example that object on this straight line where this is the distance 5 kilometer, 10 kilometer up to 40 kilometer. So object is moving from O to A to B to C. O to A to B to C. So here two quantity we need to understand, we need to discuss. One is distance and another is displacement. So let us discuss what is the exact difference between them. First of all, path length or distance. So from moving from O to C, first of all O to A is 40 kilometer. Likewise A to B 15 kilometer, B to C 10 kilometers. So in total it is a 65 kilometer. So I can say the distance traveled by the object from O to C is 65 kilometer. However, the displacement only depends upon the final position minus initial position. So what is final position here? C. What is initial position was? O. So final position C minus O. So final positions distance 15 minus 0. So displacement is only 15 kilometer. So distance and displacement both are two different quantities. Okay. Distance or path length depends on the actual path, the path on which you actually moved. However, the displacement does not depend on the actual path. It only depends upon the initial position and final position. Is this difference clear to you, student? Okay, let us take example. Here I have written that can distance be 0 and can displacement be 0? What do you think? Can distance be 0? No, it cannot be 0. Even if let's say you are moving from let's say point A to point B and once again you are coming back to point B to point A, still if let's say this is 10 meter and this is 10 meter, your total distance is 10 plus 10, 20 meter. But what about the displacement? Here you have started your journey from point A and you are coming back to your original position, that is point A. So what is the final position? A. What is the initial position? A. So A minus A, 0. So here displacement can be 0. So we can take any other example. Let's say you are starting from your home to go to school in the let's say 7:30 a.m. in the morning, and you are coming back to your home at let's say 3:30 p.m. in the afternoon. So have you traveled any distance? Yes, you might have traveled let's say 1 kilometer or 2 kilometer or whatever it is. But what is the displacement? You have started from your home and after a time you have returned back to your home. So final position and initial position is same. So in this example your displacement is 0. Let us take some more example. Here this is let's say a playground which is a square, and the length is 10 meter, the breadth is 10 meter, and one particle is moving from point A to point C. Now in this example we need to calculate what is distance and what is displacement. So distance, as you now know, it depends upon the actual path. So actual path from going from A to C is A to B and B to C. So 10 plus 10 is 20 meter. Very simple. What about displacement? It does not care about what path you have taken, whether to reach C it is A to B to C or A to D to C, or from here to here or here to here. We only have to take into the consideration final position minus initial position. So what is the straight distance? This diagonal. So according to the Pythagoras theorem, this is under root of 100 plus under root of 100, so under root of 200, so it is 10 root 2 meter. So here the distance is 20 meter, however the displacement is 10 root 2 meter. So remember one thing, displacement is always less than or equal to distance. Displacement is always less than or equal to distance, correct? Let us take one last example which is also there in your book. So there is a farm which is like this, there is a square farm, and yes, it is 10 meter, 10 meter, 10 meter, 10 meter, and farmer is able to travel 10 meter in 40 seconds. So this is from A to B, 40 second and 40 second and 40 second and 40 second. So how much displacement is there if a farmer has traveled 2 meter 20 second? So time given to us is 2 meter 20 second. So first convert it into the seconds. 2 meter is 60 plus 60, 120 plus this 20, so 140 second. So how much displacement farmer would have traveled in 140 seconds? So let us calculate. So from A to B 40 second, then this 40 second 80, then 120, and how much is given? 140. So from D to A it is 160, but here the given time is 140. So half the distance from D to A the farmer would have traveled in 140 seconds. Have you understood? 40, 80, 120 plus 20, 140. So what is the distance between point A and this? This is half of total. It is 5 meter. Okay. So displacement in 140 second, that means 2 minute 20 second, is just a 5 meter. So student, I think you must be clear, you must have understood about what is motion, and some basic understanding about the motion. Very importantly, what is the difference between distance and displacement? So now you will be able to calculate and able to answer the very first question of your chapter number 8. Okay, thank you very much.